Aloha and welcome. In this video, we're going to be talking about merge sort. So merge sort is a sorting algorithm that takes a list or an array and it divides it into half, and it takes half one and half two, and it further subdivides those into half. It keeps on going till it gets to the singular element. And when it gets down to the base unit, an array, a list, what it's going to do is it's going to sort these. So we're going to take a look. It's a little bit easier to visualize this when we're looking at the text. So we're going to start with our animation here. So it takes this list of, let's say, 6 elements here, and it determines this J value. The J value is basically we're going to split it. So that's determined by taking your first and last index, 0 plus 5 here. You divide it by 2. That's going to give you 2.5. You get the floor, that's going to give you 2. So that's going to be 0, 1, 2. So essentially you're getting 3 items on both sides there. So you've got two arrays of 3 elements each. Now what you're going to do is you're going to split the next ones. And you're going to see that you have 0 plus 2 there. That divided by 2 is 1, so 0, 1. The larger side, 3 and 11, are going to make its own 1 up. Then you'll have the larger half, or the other half being just the element 8. Then 8 is not subdividable, but the 3 and the 11 is. So you'll go ahead and you'll do the same math. 0 plus 1 divided by 2. The floor of it is 0, so you're going to have 2 elements, 3 and 11. So then you notice that a list of 1 is already sorted, and it's going to take these and it's going to put it back. Well, it's it's not going to show you yet in here, but at each level, the sorted lists are merged back into the previous one, and that is where we'll be discussing in a few minutes. We'll actually get into the algorithm to do this part. But what it does is it takes each one, moves it back into the previous array in ordered sort in an ordered fashion, and then it takes the other half and it pushes those back up. So this is going through recursion. And again, if you haven't gone through recursion in your previous class, go ahead and look at it. It's in chapter 10 of this book. So the Zybooks that we're using right now, I included all of the chapters that should have been covered from ICS 111 along with all the stuff we're covering in ICS 211. That's why we're starting at chapter 11. So go and look at chapter 10. That has all the information you need on recursion. So the merge sort algorithm uses 3 index variables. So we talked about one is going to be your the bottom of your array, the other is going to be the top, and the other one is going to be the divider. So the element at which you're in which they're calling it I is the index for the beginning of the 1/2. Then the other is going to be at the top. Actually, in here they're talking about using pointers to keep track of the first element of the lower and first element of the higher, and then also keeping track of the divider, which is J. So we're going to look at the participation activity here, determine the index J and the left and right partitions. Okay, so we get in here, we've got I is 0 and K is 4. So what that's telling us is I is 0, that's going to be the bottom here. So 0, 1, 2, 3, 4. So 4 is the ceiling of this. So we've got 0 and 4 is our 2 bookends essentially. So J is going to be calculated using this formula that you see back here, which is going to be essentially the index of the low end plus the index of the high end divided by 2, and you get the floor of that value. So for here, we've got 0, 1, 2, 3, 4. So we've got 0 and 4. That's going to give us 4 divided by 2. That's going to give us 2. It's going to be 2 even, so we check, and that is correct. So you can go through here and do the same idea. What they're asking for, this is asking for the left partition. We look in here, we see the numbers are going to be 1, 2, 3, 4, 5. So if I is 0 and K is 4, again, we're going to be dividing it 2. So J is going to be 2, 0, 1, 2. So the first 3 elements will be on our left side there. So we should expect this to be 1, 2, and 3. And we check, and indeed that is. And the upper part would be 4 and 5. So it's going to ask you questions like that. Determine J, the left side and the right side. So use the formulas that used above, and that will give you the answers. So merge sort merges the two sorted partitions into a single list by repeatedly selecting the smallest element from either the left or the right partition, adding them to a temporary merge list. Once fully merged, the elements in the temporary merge list are copied back to the original list. So think about this. As we're calling on this recursively, we're sending it the original array. Once we get into this, we're going to then create a temporary array, or we can call these lists if you want. So we create this temporary list, and what we do is we compare our two sublists, and we compare the values in each one, because each one is sorted at this point. We're comparing each one, and then we're taking the lower of each side and putting that into the merged list. Then we're going and moving over, and then we're comparing the next two values. We're continually selecting the lowest value there and putting that into our merge list. Then after we've gotten through both of these sublists or subarrays here, once we've copied all the elements into that merge list, we take that merge list and then copy that back into our original numbers array that came into this function. So if that doesn't make any sense to you, watch, we'll see some animation here. So the animation is going in here. It's running the code. And what it does initially is it sets up our left position and our right position. And we've got our merge positions right here inside merge numbers. So we need to keep track of where we are, putting our values once, we copy them from here. We need to know where we're going to be. So we've got those 3 pointers. So the next step, we're going to compare the element in the left and right partitions. We're going to add the smaller of the two into the temporary list, and then we're going to update the relevant indices. So if we take the smallest from left, right stays the same. We shift left over, though, by 1. So we do that, and then we also shift merge position over 1 by 1 because we've put in the value from down here in there. Okay, so then we go and we compare the next two values, which is going to be the 8 and the 4. And 4 is going to win out. So we're going to take 4 and we're going to put that in there. We're going to increase merge position by 1 and right position by 1. And we'll leave left position as it was. So we compare 8 and 4. They're not equal, so 4 goes up there. Then we go and we look at the next position, 8 and 18. So now 8 gets copied up into and remember that's copied up into the temporary list that we have. And we do this for everything that we have. Then once you've used up one side, then you just copy all the elements of the other side in that order, and that'll be fine. Because what's going to happen is because this is acting recursively, we're starting at the top, but we're moving down in half, 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 so that the last ones that we get to are going to be sorted. So when that bubbles up to the previous level of your recursion, these sub arrays that you're dealing with here are already they are already in order. So that's why this works logically. So now we've gone through all of one side. The left partition is empty. Then we're just going to go and we're going to copy the right array elements here up into the merge numbers array. So after that, we're going to take the stuff in merged, and we're going to move it back into our initial numbers array in the order that it was found, or in the order that we sorted it into. So that copies it back into the numbers, and then we go back. We exit out of the function. So now we're going to trace the merge operation. Trace the merge operation by determining the next value added to merge numbers. So we're looking at these two. It's telling us that our left position is 0, our right position is 3 right here. We're comparing the two, 14 and 17. Obviously, 14 is lower, so we take that. If left position is 1 and right position is 3, then we're comparing 18 to, 3 over here. We're comparing 18 to 17, so 17 is going to be the next one. And we'll pop that number in. And you can just go through and do all these because it's just going to have you trace that functionality. So here is the merge sort algorithm. So the merge sort algorithm, if we look at it, we're going to have 3 functions here. This is just the main, this is the scaffolding really. We're creating our numbers array. We're going to print it out and then we're going to merge it and then we're going to show it to everybody after it's already done. So the functions that are most important in here, we've got merge sort, and merge sort is coming in here. We're sending in our numbers array. We're sending in our bottom and our top indices for that. And then we've got integer j here, which we know is going to be used as our midpoint selector. So if I is less than k, in other words, if we have something here that's of length greater than 1, essentially, then we're going to say j is equal to I plus k divided by 2. We talked about that at the top. And then we're going to do a merge sort, which is calling on ourselves again. We're going to merge sort the first half and the second half. So we're taking I up until that j, the divider, then we're taking j plus 1 up to k, which is the top. So we're going to merge sort both of those. And then we do a merge. So after we do the merge sort, we're going to do the merge. So what is the merge exactly? Well, that's the funky calculations going on up here. So merge, we're taking in numbers again. We're taking in int I, int j, and int k. So this is our base, this is our midpoint, and this is our ceiling. So with that, we're going to say merge size is going to be the ceiling minus the floor plus 1. And then merge numbers is going to, we're setting up this temporary array that we can copy everything in correct order so that we can copy it back to numbers afterwards. Then we've got our merge position, which we're going to use to keep track of where we are pushing numbers into that merged array. Then we've got the left position, the right position. Then we set out by saying merge position is going to start out at 0 because, of course, when we're going to be copying in, we're going to copy from the first element. We've got left position being I, which is the bottom of the array. Right position is going to be j plus 1, which is going to be the first position in the right array itself, because it's right after that j divider. So then we're going to loop here. We're going to loop. We're going to say while the left position, in other words, while the left position is less than j, which is while we're still in that left side, and we haven't gone past j, and while right position is less than or equal to k, which is the ceiling of the array, while that's true, we're going to go ahead and compare the two. We're going to compare the values at that position. And if one is less than the other, then we're going to copy it into, if left position is less than or equal to the right position, we'll take the left position, put that into the merge numbers, then we'll increase the left position. Or we're going to do the same thing for the right position. We're going to say, the merge numbers is going to take the value from the right side. We're going to increase that right pointer. Then we're going to increase the, either way, left or right, we're going to then increase the merge position. So we'll move over to the next character that we're going to be copying into. So after we knock out of this logic here, which is saying that once we've used up either the right or the left, then we're going to say if left is less than or equal to j. In other words, if we weren't used up, if we hadn't gone through the entire left array, then we're going to copy out the rest of the items there into the merged numbers. Or if right array wasn't all used up, then we're going to copy those values up, and then we're going to, as we go, we're going to increase the right position, the merge position as well. So then, after we've finished this ordering of everything into this merged numbers array or list, we're going to take all of that and we're going to put that back into numbers. So we're going to go through, we're going to loop over our merge position, that temporary array that we created, and we're going to copy the values one by one into numbers using the floor and the ceiling that we had. So that's how it works. It's a beautiful recursion. Again, if you aren't familiar with recursion, go and take a look at chapter 10. It'll get into that. The next part here, we're talking about when we're talking about the efficiency of the algorithm. Merge sort itself is going to be O of n log n. So it talks about how the merge sort divides the input in half until a list of one element is reached, which requires log n partitioning levels. So at each level, the algorithm does about n comparison selecting, copying from the left and right partitions, and that's going to yield you about n times log n of comparisons. So it requires O of n additional memory elements for the temporary array of merged elements, and for your final merge operation, the temporary list has the same number of elements as the input. So talks about how some sorting algorithms out there, it's going to sort the list in place. It requires no additional memory, but they're, obviously going to be more complex to write and understand. So if you think this has been difficult, with the three different pointers here, it can be a lot more complex if you're doing in place work there. So our next participation activity, looking at merge, sort, runtime, and memory complexity. So how many recursive partitioning levels are required for a list of 8? Well, you're going to take 8, you're going to divide it in half. That's going to give you 4. Then you're going to divide that in half. It's going to give you 2. Then you're going to divide that, and it's going to give you 1. So that's going to be 3 partitioning levels. So you put in 3, yay, that's correct. Then how many for a list of 2048? Let me give you a hint here. So 2 to the 10 is 1024. So you raise it one more time to the 11. That's going to give you 2048. So essentially, you can easily figure it out by, so that's going to be 11 because it's, yeah, so it's logarithmic there. So you can go ahead and solve this each. This other one, this is one you just have to think of what it means, to have that temporary merge list. So and then the last part, the challenge activity, you're going to look in here. What arguments should be provided to merge sort to sort the numbered list here? So what does merge sort take? It takes your array, your lower and your upper bounds. So your lower bound is going to be 0, and it has 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. So you should be putting in 0 and 8. Okay, 8. Let's check, see if that's right. Yep. So go ahead and go through the 5 different ones here. And yeah, so this is merge sort. Again, a nice little algorithm. This is a lot, I think, less painful than quicksort. It's a lot easier to understand. You're just taking that big array, you're dividing it in half, and then you're going to, take your 2 halves. Then you're going to go ahead and divide those in half, go all the way down. Then you're going to, as you're bubbling up, you're going to be putting everything in order into a temporary array, and then you're going to take that, copy it back into the array, and it's so it's recursive. So this builds up as you bubble up to the top. So yeah, go ahead, try this out. Let me know if you have any questions. Again, I'm just an email away. We can set up a Zoom to talk about this. Otherwise, I'll see you in the next video. Aloha.